Right, this is video 5.5. Today we're going to be talking about coordinate geometry, which is pretty commonly used in a lot of computer graphics. The way your computer does it, it is going to use a coordinate system to create the images, and basically using simple geometric shapes, and then they can turn those figures into realistic figures that are sometimes used in your CGI in your movies. But that's all going to be from coordinate plane geometry. So here's our coordinate plane. If you have 2 points on that plane and you connect them using a line segment, you can define this line segment using what's called slope. So your slope is going to describe how steep the line is. And your slope is defined as your vertical change divided by your horizontal change. Another way we'll just talk about it, especially next year when we're doing a lot of graphing, is our rise over our run. So vertical change is how far up or down you go from one point to the next, divided by how far you move right or left to get to the next point. So in this particular line segment, if we're talking about rise, we're going to start with the run though. In this particular segment, we're going to talk about our run first. How many spaces over did we have to go to move from one point to the next point? So we would count that 1, 2, 3, 4, 5, 6, 7, 8, 9. So our run would be 9. And then how far would we have to rise to get to the next point? We can count that up as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our slope would be like 11/9. That can't be reduced, but if it was reducible, you could reduce it. So you'll notice that this makes, if we're looking at it as geometry, right? So your slope, if you're adding your rise and your run, now we've made a lovely triangle, right? Another way of describing the slope would be whether it is a positive slope or a negative slope. And it turns out that this one is going to be a positive slope. A positive slope is anything that is aimed in that direction right there. So in general, a positive slope looks like that. A negative slope is going to be tilted the opposite direction. You can have a zero slope, which is a horizontal line, because you don't rise, it'll run at all. So if you were going from this point to this point, what would your rise be? Your rise would be 0 and your run might be 4. Well, what is 0 divided by 4? It's 0, so we would say our slope is 0. You can also have an undefined slope, which is going to be your vertical line. And the reason that is undefined is because if you're going from one point to the next, maybe you go up 2, but you don't run at all. And you can't actually divide anything by 0. Anything divided by 0 is undefined. So that's why we would say is undefined. So if we have this figure here and we are wanting to define the slopes of particular lines in our figure. So we are going to determine whether or not the slope is positive, negative, 0, or undefined. So let's start with line KN. So if you find your K and you find your N, its slope, how would we describe that slope? We would describe that as a 0 slope because it is horizontal. What about KL? Is that a positive, a negative, a 0, or undefined? Remember, 0 has to be horizontal, undefined has to be vertical. Therefore, this is either positive or negative, is pointing in the positive direction, so we would say it is positive. What about LM? LM, let me erase that one. LM is here. It is attached to a vertical line, so a vertical line we would say is undefined. And LN is going to be this line right here. It is not vertical, it is not horizontal, so it must be either positive or negative. It is headed towards the negative side, so we would say it is negative. Let's go ahead and find out what our positive and negative slopes are for the two lines that are positive and negative. So from K to L, how far would you have to rise to go from K to L? How many lines up you would go? You would have to go 1, 2. So we would say 2 over. And then how far would you have to run? 1, 2, 3, 4. We can reduce that and we can say the slope is 1/2. Let's look at our slope of Ln right here. Going from N up to L, how far would you have to rise? You would rise up 1, 2. And how far would you run? You would run backwards, so -1. So we would say this has a slope of -2. So what are the slopes of parallel and perpendicular lines? How do they look? Well, it turns out if you have two lines that are parallel, remember parallel lines don't cross at all, they're going to have the exact same slope. So if you have two lines that have the same slope, then they have to be parallel. So if you have line A, if line A has a slope of 1/2, and you know that it is parallel to B, what does B's slope have to be? B's slope has to be 1/2. They have to have the same slopes. Okay. Now, if your two slopes have a product of -1, then they're going to be perpendicular. And what I mean by that is if, let's say, we had the slope of A over B, we would know that it's perpendicular, and that's the sign for perpendicular. A over B is perpendicular to -B over A. Because if you multiplied AB times -B over A, remember when you're multiplying fractions, you can reduce if they're the same. So those B's would reduce down to 1, and your A's would reduce down to 1, because they would disappear all together. And so you would have a -1 when you multiply them together. So that would be the example with letters. Let's look at an example of perpendicular slopes in numbers. So let's go back to our A is 1/2. So if we have a slope of 1/2, what would the slope need to be in order for it to be perpendicular? Well, I'm going to flip these two and put a negative out in front of it. So it'd be -2 over 1. The other way you could write -2 over 1 would just be to say -2. So if line A has a slope of 1/2 and C has a slope of -2, then we know that they are perpendicular. The other thing to keep in mind is that all horizontal lines, so if you have a slope of 0, that is going to be perpendicular to an undefined slope. So all vertical and horizontal lines are going to be perpendicular. So let's find which of these lines, kind of crazy to look at, are perpendicular and which one are parallel. So to do that, we need to find out what their slopes are. So we are going to look for at line PQ here, see what its slope is. I want you to try to find it as I find it. All right, I'm going to go from P. I'm going to count how many slashes up I need to go. So you have to run or rise 4, and you would run 3. So its slope is 4/3. Let's look at RS. I would rise 1, 2, 3, 4, 5. And I would run 1, 2, 3, 4. So 5/4. Let's go from A to B. So I would rise 1, 2, 3, 4. And I would run 1, 2, 3. So just looking at those, because there's no way that any of those lines are going to be parallel to the other ones. Remember, we know that parallel lines have the same slope. So which of those three are going to be parallel? We could say that line PQ is parallel to line AB because they have the same slope. Let's look at the other ones. And we're looking for P to A right here. These are all going to be negative slopes. I'm going to be going down 1, 2, 3. And I'm going to be running positive 1, 2, 3. So we would say it has a slope of -1. GH here, we're going to go, let me erase that. GH, we would go down 1, 2, 3, 4. and we're going to run 1, 2, 3, 4, 5, so negative 4/5. And then xy, I'm going to go down 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7, 8, 9. 7/9. So are any of these three parallel? They don't look parallel to me within each other because none of them have the same slope. Are any of these 6 perpendicular? Remember, they're going to be flipped and opposite if they're perpendicular. Well, none of them are 9/7, so it can't be that one. One of them is 5/4, which is going to be the opposite of this one. So we can say that line RS is perpendicular to line GH. And that's the only one that we would be able to say that about. So we can say these two are parallel because they have the same slopes, and these two are perpendicular because they have a product of -1. They are opposite and reciprocal. All right, so sometimes you're going to need to graph certain points to be able to form a quadrilateral or another shape. So a quadrilateral means it's going to have 4 sides. So we're going to graph these 4 points. They will be our vertices. We'll connect them with line segments, and then we'll classify quadrilateral as being like a parallelogram or a rhombus, a square, rectangle, whatever. Based on the previous chapter, we talked about how different classifications of parallelograms and what is special about them. All right, so we're going to graph these. Remember that this first number here is our x, and our second number is our y. We move right or left along the x-axis, depending on whether it's positive or negative, up and down along the y-axis, and then we'll put our point. So we start from the center here every time, this 0. This graph is a little hard to see, but because the numbers are right in the middle, so it makes it look like the line is extra down, but it's just keep in mind that this right here, this line is -1. All right, so J is at -6,3, so I'm going to go over to -6, and then I'm going to go up to 3 and put my point. That is J. K is -2 and 3, so that's K. L is -2 and -1, which is going to be at that point. That one's what we got to be careful about. M is at -6 and 1. I'm going to connect my lines, and now we can classify our quadrilaterals. We definitely have a quadrilateral because it has 4 lines, so this is a quadrilateral. We would say, if we look at the slopes of our lines, this has a 0 slope and this has a 0 slope. So it's one pair of parallel sides. That is a vertical slope and that is a vertical slope. So we have 2 pair of parallel lines, which means that it's a parallelogram. All right, let's count how long our sides are. We have 1, 2, 3, 4 on the top, and 1, 2, 3, 4 on the side. 1, 2, 3, 4 on the bottom. 1, 2, 3, 4 on the other side. So we have 4 congruent sides, which means that it can be a rhombus. And if we're looking back at the slope, we said that a vertical and a horizontal line have to have a 90-degree angle. So that one's a 90, and 90, and 90, and a 90. So we have 4 90-degree angles, which means that this could be a rectangle. And if we have 4 congruent sides and 4 congruent angles, then it has to be a square. So there's lots of ways we could classify this quadrilateral in particular. All right, this is another figure that you will use to answer your questions in your homework quiz. I'll go ahead and copy that down. I'm pretty sure the quiz, if I remember correctly, just has to do with whether or not it is a positive or negative slope, whether or not what the slope might be on it. So be able to answer any of those questions about these figures. And I will see you in class.